Good afternoon, everyone. Hope you all had a great time listening to some great presentations this morning. And thank you so much for coming here to hear our presentation. Hope you all had a good lunch. So now sit back, relax, and we'll walk you through our trials and tribulations as we went through our QA journey with continuous improvement. This was a path we took almost a few years ago, almost 6 to 7 years ago. And with every step, we learned quite a few things, right? Have you ever had time when you are thinking, will my QA team ever be able to finish this sprint testing? Will we be able to give a go, no-go decision in time if you have like 2-week sprint releases? Have you ever said, oh no, it's just there are so many things to be tested, very little time, and we really don't have time to finish testing, right? Or even the other most pertinent question that comes up all the time. When will my dev teams finish their code so my QA can actually start testing within the sprint? Hope, does these questions resonate with you in any way? Or is it just us who had this problem? See, I see a few head nods. Awesome. And based on this quote, which is very, very true, you have 20% of the software that contributes to 80% of defects almost all of the time. A few years ago, we actually had a very large migration project. This migration project was complex. It's more a program with multiple projects, very chaotic development timelines, 2-week sprint releases, and complex integrations all over the place, right? And this was a very large program that had very tight timelines, and we were supposed to test everything within the sprint. But the problem that we had was, given multiple projects that were contributing towards the program, we had integrations, and we would see a large number of critical defects across the board, right? These defects were critical. We couldn't move forward. And the question that our test teams always had was, where do we focus? We have these little bundles of defects that are showing up, and they knew exactly which components, but the team was getting pulled into multiple things. A product owner would say, no, I need you to do this. Or somebody would say, no, we need you to do this parallel testing. In spite of having a test strategy and alignment with the product owners, with the program leadership on the test strategy, the test approach we followed, it still felt like the team members would get pulled into all possible directions. That was when the problem that we actually had to solve was, how do we narrow down the focus? How do we bring everybody down to that one single alignment of, for us to complete sprint testing, this is the small piece of software that you would want to test, or these are the specific integrations that you would want to test. With that, I'm Latharao. I lead a large QA. I'm a QA director, and I lead a large QA team from Perficient. We are based off of Ohio, and I have my partner,
Sylvia Sesostris, and I'm also at Perficient, QA director, mostly leading the QA functional team. And for you guys that haven't heard of Perficient, we are a digital consultancy. We're global, and we provide end-to-end software solutions.
This is a typical scenario that we see, right? A common challenge that we all have. You have a complex product, you have omni-channel, or at least the project we had, omni-channel, constant scope changes. And as you know, if anybody heard this morning when Melissa was giving her talk, she talked about you have automation, but how much automation is really enough? The problem that we actually had was conflicting directions from product owners. Hey, we need to do complete regression. Everything has to be automated, but it has to be a complete regression. And the QA and the leadership's issue was You asked for automation software, you have automation software. You wanted so many people on the QA team, you have people. So why are you not able to complete your QA testing on time? And that was the problem that we set to solve. How could we actually, in spite of having automation, in spite of having a QA cadence, how could we narrow down the focus and be able to predict when and how could QA complete its testing on time? How many resources did we need for this next sprint? How much of integration work did we do? What were those small components that were leaching our time across the board? So that was the problem that we started to solve. And the first step in that solution was using predictive analytics. A few years ago, predictive analytics was the big thing. Everybody used predictive analytics, right from products to the process. And we said, everybody is doing it. So why not we see what predictive analytics is all about? So what is predictive analytics? Anybody use predictive analytics within your development or in your QA cycles? OK, so I would love to explain what that is about. It's all about taking your present day data, your organization's historical data, and sometimes even your current data, and be able to make meaningful predictions about your future. So in a QA context, you would find what are those critical factors, right? Is it that the devs don't complete their development on time? So if the development teams don't complete QA or their work on time, and if it is a 2-week sprint, you barely have, maybe you get the code on the Tuesday or Wednesday of second week. You have 2 days or 3 days time to be able to even complete manual testing, let alone automation. You at least have only 2 days or 3 days to complete testing if you don't want your team members to be working over the weekend so they can finish the QA on time, right? So as part of predictive analytics for QA, we went about finding what are those critical factors that we could use. And we would say, just because we went to the Scrum teams, to the Scrum of Scrums, and we said, hey, we couldn't finish QA. It's because the devs didn't complete it, or it's because of whatever reason. We did not have a process that was data-driven. We didn't have the backing of data to show that. And it was almost like, oh, QA is not getting done on time. So we said, we have to use a very logical approach. And our approach was take test data metrics. Right? So test data metrics from maybe the lower environments. The production data, the issues that are happening, the critical issues, or any issues with high impact that are getting logged in the production systems. And we said, let us gather all of the data and use that to show which components, what areas were the most problematic. So it would help us align our QA team members, our automation resources, and even our pipelines, right, to the most, how we could use them in the most effective way. And we looked at something like the production logs, the test data metrics, and we said, let's implement this predictive analytics. And predictive analytics was all about finding out what is your confidence in completing QA on time based on the data you have today, based on the data in the last 6 sprints, based on the data for this program in the last 1 year. How would we track the most problematic areas? Give it an analytical score, right? Higher the score, it meant that, hey, there is higher confidence. Lower the score, those were our key problem areas. We also derived at an confidence efficiency or an efficiency confidence %. The higher the confidence, Then we said, yes, if it was 100%, it meant that we, with the team that we have now, we will be able to manage what's coming next. Let's say it fell below 60%. Something within the next sprint had to give, right? Either the scope had to be changed, something within the QA process that we were using had to be changed. So using predictive analytics, we basically were able to find the areas that had the most number of test failures. And using production systems, we were able to get real-time feedback loops. Providing the predictive analytics score and our confidence percentage, we were able to allow for the data-driven decisions. And given that you were able to do data-driven decisions, we were able to implement truly risk-based testing, right? And we also had this data was available across the board to the product management, to the leadership, to all the devs. So everybody had visibility to the hotspot areas. And we were now able to say, oh, yeah, these are out of 20 different components, these 3 are the most problematic. We were able to narrow that down. So that was how we predictive analytics helped us. What were some of the data points that we used for analytics? So you needed to gather data, like I said. And within the lower environments, we used tools like the test management tools, the CI/CD pipelines, and some of the logs that were written, especially if these were like native mobile applications using the Firebase or the Android systems. From production, we use the APM tools and then the production logs. The cool thing about using the test management tools was this was one place where we actually, every day, test defects got logged, right? There are multiple test management tools in the market, some licensed, some open source. Sometimes we have very large clients that still use only Excel. Right? And all of them work well. For us to use predictive analytics, all of them work well. But our tool, the choice of the test management tool that we chose was PractiTest, because we were able to do tagging within the test cases. And it also gave us some very cool dashboard capabilities. From the CI/CD pipelines, we were able to look at how many jobs were failing. A constant report of, hey, you have scheduled jobs. How many jobs were failing? We created some dashboards. It was showing those dashboards. From APM tools in production, like your Dynatrace audits or your Splunk logs, we actually wrote, I come from a development background, so any place where you can write code is very exciting. So we wrote some automation crawlers to go and look through the production logs and write them all to a log. So this was some of the data that we got. But what was the data that we actually collected? Things like test cases, total number of test cases that we could get from the test management tools. How many of those defects were high priority? How many of them were of a higher severity? And what were the components that were, especially within the APM tools, the production logs, the pipelines, what were those components, what were those jobs that was giving us, that were failing the most, right? We used this information, so we were able to collect information on where should our focus kind of move towards. Anything that had, let's say, if we had test cases that were in withdrawn status, it indicated that it was a test case that was not actually valid. We had a test case, we had a defect assigned, the developers and the product owners looked at the defect and they said, hey, it is no longer valid, so it means it was a withdrawn test case. So we now knew to go back into our our test management tool and our test cases and say, okay, this is no longer a valid test case. So, it was almost like we were creating a lean system of test cases, right? With that, let me just quickly see if I gathered everything. So with predictive analytics, we used a multitude of critical factors. Some of those factors were from the APM tools, from the production tools, from the test data. But what we were able to do is create an algorithm. That was the cool part of the predictive analytics. We created an algorithm which assigned different weightages to different factors. Something happened in QA. So that QA test cases passed, failed, got a certain weightage versus what were you doing, the process that was being followed within the development life cycle, the grooming of the stories, the complexity, the time it took for certain components to be completed by the developer so it could come to us. So our algorithm had all different factors that contributed to the success of us being able to deliver the product on time, and we added those weightages. So based on this, we got two distinct items. One, a confidence and efficiency percentage that said, yeah, if the trend goes this way, this is your efficiency percent, right? And the other thing was a predictive analytics score. That predictive analytics score showed us the effort, the amount of effort needed from the QA team. Anything that said 100 meant that we were good the way we were. So we could continue with QA. As the number went down, it was an indication to us that we had to look into, is more automation needed? Do we need to go check something within our QA process? Is there a need for us to add more QA resources or readjust our QA resources to see how we could adjust the QA organization, the QA team members' assignments so we could fulfill our work, right? This, so far, once we got the algorithm right, it was sweet. We now knew, cool, these are the 5 components. Hey, developers are always late on these components. So anything that is data related, there's a lot more work. So as the numbers went down, based on that predictive analytics score, we had the data to take back to the program management. It helped them realign the sprint commitments. Week after week after week, we showed, hey, these are the components based on these predictive analytics scores. These are the components that are taking too much time to complete test development, so testing gets very little time. So based on these kind of data-driven facts, we were able to reduce or we were able to realign on the sprint commitments from the program management team, which was an absolute help. But it also gave us some indication as to what were the weak spots within our QA organization itself. The more number of flaky tests we had, it showed, oh, this is something that we have to test. The more number of pipeline failures we had, I mean, having automation and running them through the pipelines, it's been something we've been doing for a very long time. But the more number of pipeline failures we had, or the more number of tests that were waiting in the queue to be executed, meant that we needed to scale something, and these were changes we needed to make on our QA side. And at this point, we had an analogy. The analogy was, yeah, you go to a doctor for your annual physical checkup, right? All of us do that. Once you go to the physician's office, they'll administer a few tests, and based on those tests you go through, you get test results, right? Your cholesterol may be high, your blood sugars may be way down, but this is just a point in time data. What do you do with that data? If there is some action you have to take, predictive analytics, for all the excitement we had in implementing, it worked very well up to the point where we had the scores. And once we had the data, it was like, OK, what next? That was our indication of, yeah, hey, we need to do a few more things with our QA practice that we needed, and this was like our second step in our continuous improvement journey. We actually had a large number of automation frameworks. As a consulting company, we cater to many different clients. So we use a combination of open source tools. We use a combination of licensed products that the clients want us to use. And we started to look at our automation accelerators that we have built. And we said, OK, the first thing that was going well for us was, yep, you already have automation frameworks. But based on some of the results that we saw, maybe we needed to make the tests smaller. We needed to be making them more modular. The other item was, how do we make sure, it's kind of like eating our own dog food. How do you make sure that this automation test actually works? So we started to write unit tests. If it was a component level test, or if it was, let's say, if it was a web page, and we were testing different CTAs on the page, we went about creating unit tests. If it was looking at the lower tests at the lower end of the testing pyramid, the integration test, we started to write some unit tests for that. We made them modular. After we made them modular, we said, OK, the automation frameworks are now doing well. We also made sure that we looked at all the test cases, and we said, is this just having 6,000 tests, having 10,000 tests the way for us to go? Or do we create a criteria that would help us pick the most suitable candidate for test automation? So a lot of improvements went into the automation framework. Then these had to be put on a DevOps pipeline. And we already have pipelines. But then the more projects that got added to this program, the problem we had were tests were waiting in the queue. We could not build enough agents to keep up with it. So we said, OK, we have to now become a more technical, become a technology evangelizer, and we added containers. So we could add the feature of auto-scaling to our pipelines. So the more tests came into the queue, we added more pipelines, and we created an auto-scale feature. So as tests came, it would spin up a new agent, and then the test would get executed right away. Once we had tests executing, how do you now go back and look at the progress, right? Do you know if the tests are passing, if the tests are failing? So we went and added a few more dashboards to these pipelines. Sometimes it was maybe a Radiator plugin within Jenkins, or within ADO, building up the dashboards to start showing the data there. Once these three things, the automation frameworks, the pipelines, and the dashboards were done, we actually looked at, hey, these are all great. We still find errors. Where are these errors coming from? Most of those errors could have been sorted with this increase in the automated unit tests. We now had to go engage with the dev teams and work with them on how to strategize and how to bring a little bit more mature unit testing strategy from the devs. So anything that came to us, the unit tests were done, and they had at least 90 to 95% code coverage. With these 4 items, we felt it took us maybe about a year or two to stabilize these changes we made. We were at a good point. Then came the next step in our improvement, a continuous improvement. What we felt was, as with every sprint, these 4 items, we could do them in parallel. Most of the time, we could do them in parallel. And these could be isolated events that our teams went away. They went and built the automation framework, stabilized them, the same way with the pipelines and with the dashboards. Coming down at a sprint level, we thought it was a whole different story. Every sprint brought with it its own front-end unit tests, which were becoming flaky. And what we noticed was that we also had a lot of script maintenance work. In spite of all the work we put within that automation stabilization, we still had flaky tests, we still had script maintenance, and with that, we said, okay, let's go and look at some self-healing, AI-based, machine learning-based, self-healing activities to reduce the flaky tests. That is something that we continuously, iteratively do with every sprint. Now came down to this very last item. We had this large, if you remember, as I said, our regression suite was large. And given that it was spanning across multiple projects, when there was a big release, like let's say there was a release at a program level every 3 months, we had to go through at least one hardening sprint and running regression. There was just not enough time nor enough pipelines to run through the regression suites that we had. So we went and we have a team that is very excited about innovation. They want to get their hands down and dirty to write code and see how they can bring in improvements. So we went and added some automation where we could do smart regression. Looking at the release notes for every sprint, that was enough information for us to be able to say, these 20, these 50, these 70 different components had changes. So maybe we will organize our regression in such a way that the first pass of regression will only be using the test cases that contain these X number of components, which cut down our time drastically, and we were also able to, this really brought up a lot of improvement in our space. Once we had these 3 items in an iterative fashion, we used this data to train our PA model. So earlier we had a certain set of weightages that we defined, but with the weightages, as we had more data, we went and trained our PA model to be more smarter. And each one of these items created their own dashboards. They created their own reports. And they created their own reports. And the problem, we now had a different set of a problem. The problem was, earlier, we would have to go wait for offshore to complete testing, look at all the test results, do the consolidation. I'm sure you all go through it, right? You wait for the test teams to go look at the automation test results, consolidate it, and then send us the final testing status for the day, whether it's offshore, onshore, nearshore, whoever that team may be. And we didn't have a way to track our progress. I'm now going to give it to Sylvia to talk about the tracking, how we track our progress.
So tracking the progress. So if we go back to the health example, so you went to the doctor, you got your cholesterol check, it was high, and then you did the remediation, you walked, you started walking, you did dieting, whatever it was. But how do you know that what you're doing is taking you to the right path? How do you know that you are really lowering your cholesterol? You need some visibility and some tracking into what you're doing to get that feedback to know that you're in the right direction. correct? And that's exactly what we did. So we created multiple dashboards. We used our test case, our test management tool, PractiTest, and we also created dashboards for our automation. We built listeners in our automation frameworks that basically took real-time data and fed them into those dashboards. And we'd like to share some of those dashboards with you today. So before we created the dashboard, we had to decide what are the use cases that we need for those dashboards. So we wanted to make sure that it provided real-time QA status on a daily basis. We wanted to look at the specific tests that we ran on a per release or in a certain date or a certain time period. And we wanted to identify most of the failing tests or environments. We have one client, for example, that has 9 lower environments, then a UAT environment, and then a prod preview environment and a production. So how do we have to get data from these environments, see which one gives us the most headache, right? And then we had to be able to revisit the QA metrics. So that's giving us the specific time period. So what metrics are we going to collect for this dashboard? So of course, time frames, given either specific dates, like from May 2022 to May 2023, or 6 months or 30 days. We, again, wanted to look at all the environments, again, for this one particular client. We wanted to look at the test suites executed, the number of test cases that we ran, and then, of course, we wanted to see where the problem areas were in the application, complete with, which components had the most defects, and what are the defects that happen most often, and which ones are the critical ones. And then, of course, the one which you'll see later that we actually made huge improvements on is the automation runtime. So with that, we'll give you a couple samples of our dashboard. We start, with the program level. As you can see, this one gives you an immediate visual of your program level, whether for your projects, the pass rate, fail rate. And then you can see it on the individual projects as the next one. And then the one after that is your runtime. And then you can dig down further into the project level metrics where, we're showing you the daily executions. We can show you all the different parts, all the different projects and their pass rate. And then here, not to overwhelm everybody, we just showed 2 environments, production and QA.
And these are all real-time dashboards as test executions occur. This dashboard gets updated, so there is really and this doesn't have to be purely for a front-end application. Anything that you are building your automation frameworks for, let's say it's visual testing, it's your back-end API level testing, load performance, any type of a test, all we did was add those listeners in, and we built these dashboards to provide real-time information.
If you guys have any questions, please feel free to jump in. I know we're kind of going at a fast pace here. So the next sample is the QA health. So what we wanted to show you there is basically the test cases, their pass and fail rate. We wanted to show the daily pass-fail rate to see if there's anything outstanding that happened. Maybe there was a release, we got a huge, all of a sudden our test cases aren't passing, so we can go back to the development team. And then we have our verification points. And those are checkpoints within the test cases. Some of them are critical, which would fail your test case, and some are just informational. Again, we need to pay attention to them, but it gives us an indication of where's the criticality of our failures. And this is the one kind of shows, we're kind of proud of this one, even though it shows us at the very beginning that our regression suite, this is showing runtime. And so if you see in 2021, our runtime was nothing to be proud of. It was like 33 to 34 hours for this particular regression suite. But this is exactly what the dashboard helped us do. It actually pointed out this huge issue. And then that's where we then went in, and the slide that Latha talked about for the continuous improvement, looking at flaky tests, looking at self-healing, smart regressions, implementing that, as you can see, about a year and a half later, we were able to reduce for that same regression suite down to about 10 hours. So that's a 400% reduction, which we were very proud of. It was a phenomenal change. And that was really what gave us the visibility to do this, was the dashboards. So the real benefit here is the input we got for potential areas of focus, for optimal regression strategy, and reduction in unwanted test cases. The next sample is the error trends per month is also what we looked at for each of our applications. And that one basically showed us a hotspot of all of a sudden you see that in March, things spiked. And so that one, again, we could go back to the development team and we could fix whatever issues happened at that time. So with all of that, with the dashboards being our eyes to where the issues are, what did we learn in our journey? So predictive analytics is just the beginning. It's a good guideline. It is just like your test result when you go to the doctor. Your cholesterol is at this level. Now you need to do improvements to reduce it. That automation is not enough. As Latha already stated, we have large repo of QA automation. We have a lot of accelerators, but still automation is not enough. We do continuous testing is great, but orchestration bandwidth and continuous monitoring is very critical. The QA governance is also extremely critical. You have to be flexible to adjust and adapt. So just like if you're going down a path and you get the feedback, it's not working, you need to redirect. So you have to have that be able to adjust and adapt. And then you have to implement the continuous improvement cycle. And it has to be continuous and iterative.
And in our mind, this was almost like when we talk about the doctor's analogy and the annual health checkups, this to us using the dashboards, and this is our solution. Doesn't have to be everybody's solution, right? But this was our solution to come up with dashboards, real-time dashboards, which would basically showcase the data. And for us, it was almost like using the variables where you watch your health metrics every day. Maybe you have a Fitbit going on. Maybe you are using a pedometer to watch the number of steps. You could be doing all of those health-related improvements, but unless you have a visual every day that tells you, oh, I don't know how many of you watch how many steps you're walking every day, right? The day you look at your metrics and you say, good job, I did 15,000 steps, there's a little skip in your heart and you feel very happy. That's the rush that these real-time dashboards give us in the morning. Or we become aware of problems right away. Oh, why is automation not run today? We then can make a call, or you go down and look at your pipelines and you say, something got stuck. Something is not running. Or why is it that we are able to finish, usually this test takes us 20 minutes. Why did it finish only in 5 minutes? So there is a real-time feedback loop that it provides. Whether you have most of our team members, like we have a large number of team members who are automation engineers and SDATs, but we also have QA team members who have the domain knowledge, but they are not very technical. It gives them an opportunity to go look at that dashboard and be able to interpret the results and ask valid questions. They may not have to always go to an ADO dashboard to see what happened or log into the Jenkins server and see what happened. This dashboards to us was a solution irrespective of what kind of a project. Last year, we did a very large data migration project with about 80 petabytes of data. just doing parallel executions in production and in the test environments. And the only way we could actually stay sane was by watching the metrics, real time. Not just as long as we give the access to these dashboards to the project leadership and to the program leadership, they are able to see it. No one has to actually wait for an email to come with the status. They are able to look at it right away, and it provides that quick feedback loop. So
with that, we would ask, what is next in your QA journey? And has this provided you any input into
or do these problems resonate with you? Have you seen these kind of problems and you say, yeah, this is a normal thing for everybody going through their QA journey?
So we have about 15 minutes, right?
Questions for us, yes.
So questions.
I have a question. So one of the graphs you showed was from July of 2021, and then you showed a reduction, a 400% reduction in 2023. Is that the timeline to implement the
No.
predictive analytics? Like, how would you for a lot of the engagements that our company works in, we are not with these projects for more than like a year or two.
Right.
So is this something that can be implemented in a very small, very tight time frame, or is predictive analytics something that you need to have more time to utilize and to really see the benefits of it?
Okay, so the longer you implement predictive analytics, the larger your data set is going to be, right? And you can start to look at, maybe you may not need to know all 2 years. If your program was going on for 2 years, you may not need to have data for 2 years. You could still be looking at what was my 3-month trend, right? The example that we showed here was we work on a large engagement that we own this engagement, and this was just our data point to showcase here. You can see it. You can see the changes very, very quickly. On this dashboard, one of the things that we did was, one metric we gathered was every day we look at what are the defects, what are the errors that got logged today. Let's say you have a flaky test. Let's say there was an assertion that failed. Let's say there is truly a defect that we found. All those defects, all error messages, we have a visualization on our dashboard that shows you the top 50. You can select how many ever you want, the top 50, the top 25, right? It shows us that the kind of errors that we are seeing. It also shows us, one of the data metrics that we pulled was, what are those components having the most number of defects or the most number of errors? For you to find this information, maybe you do this for 2 or 3 sprints. 3 sprints is 6 weeks. Let's say you have a 2-week sprint. 6 weeks time is enough. The first sprint you implement, right? Second sprint, you start to gather data. The minimum time you would need is up to the 3rd sprint, because second sprint, you are gathering data. 3rd sprint, you already have information to compare with. Right? And every sprint, it's very likely that you could have the same user story that is getting morphed along the way, or you could have different components. And you could, in a matter of 6 months, you are actually going to look at, this will give you enough data to say what components were delivered late to you, which is very, very important from a QA perspective. How many of you in the room have your testing teams waiting for it even into the 2nd week? If you have a 2-week sprint, the Monday, Tuesday, Wednesday of the 2nd week, you're still waiting for the delivery of the code. And you are able to highlight those right away, right? Because that's a metric you track. That's information you can take back to your program leaders and say, hey, this is a pattern we see. Right? So the feedback loops are quick. At a minimum, I would say 6 weeks to 8 weeks is what you want. You are going to, the value we got from this is, in spite of me being an automation engineer, there's really no way you can go and look at the defects or the errors your automation logs are spewing up every day. You need a set of team members to look through it. It may take them 4 hours. It may take them 5 hours, right? So instead, you are now able to see it right away on your first thing you wake up, and let's say your execution ends at 8 a.m. in the morning. You have the information. You know what developers to go to because you have a critical issue you're seeing, or you know what tests have become flaky. And you can go back to your QA leads and say, hey, these are the items that need fixed. So at a minimum, I would say you would need 6 weeks, 3 sprints. And from the 4th sprint, you can start to see a big difference.
Okay. And then, I'm sorry if anybody else had questions. Would you expect there to be a minimum number of team size that you would want to see to use predictive analytics effectively? Or because we have team sizes that can range from like a 3-person team for QA up to a 20-person team.
Right.
Is there like a cost-benefit analysis for number of team members to use it effectively?
So it all depends. It depends, in my opinion. Again, this is my personal opinion. It depends on the complexity of your project. If you have a very simple project, 3 team members, 3 developers, and you're able to manage your QA and your development cycles well, why go fix something that's not broken? But for us, the problem was we had, at least the data migration project, we had about 40,000 jobs, right? And we had 20, 30 domains. When you have a small team, and again, at no point in time will you ever say, oh, my QA team is too large. They have nothing going on. They're just sitting idle. That just never happens, right? But how do we go back and make sure that you have the data to reassign your QA team members to the right projects for the right sprint? In my opinion, I really don't think there is a team size limit. But we also did not work on very small projects. It is all about identifying what are those critical factors that you want to start collecting. Do you have very complex workflows? Or do you have large integrations with external vendors, with internal services, and it's a spider web right there? So if you are trying to get a pulse on what would be those most critical factors that you want to measure, I think that's about what you would need. The team size, in my opinion, really wouldn't matter.
Okay.
Any other? Sure.
You said you guys use something called PractiTest.
Yep.
And I also saw in your continuous improvement loop there, it was feeding information back into the predictive analytics model. Do you need a tool to start using, or a platform to start using predictive analytics, or what can you do?
No.
Like we're a small company, we don't have access to a lot.
Right, absolutely, because when I started to talk about PractiTest, I also said we also have clients who use Excel, right? So what you would need, we use, you do have a lot of commercial QA products that bring in the predictive analytical score with it, but what we used was a very simple Excel spreadsheet. When we started, we said, hey, what are the things that we want to start with? The simplest thing that we started with was, let us take this sprint. Let's say we started off a program. That was sprint 0. We had all of the backlog. We added all of the user stories to that Excel spreadsheet. And all we started with was total number of test cases, right? Total number of test cases. How many passed, how many failed. That was the simplest thing we started with. And then we used the weighted averages from Excel, like the sum product, and we came up with our algorithm. And every week, the first week would just be data that you are entering, right? The next sprint, when you go, it'll be accumulation of sprint 1, total number of test cases, pass, fail, and then you do the sum product of each of those related fields. By the time you come to second sprint, you now have added the cumulative factor for your first and the second sprints. Now you go down to the third sprint. Any other data, any other factors you want to add, the complexity, all of that could now be added in the following sprints. So you really don't need anything, even if you have a very small company. For you to be able to do this, you just need Excel spreadsheet. And the buy-in from everybody. At the end of the day, we know from QA that you can do testing, you can show data, but if you can even give a no-go decision for the program, but then at the end of it, it's the leadership who decides. We are only providing our analysis of it, right? So this is something that you can start to use this data to showcase it, where your problem points are, and any development items that you would want to make recommendations to, you can use this data with your program teams.
So it sounds like you said some product is the formula that comes with Excel.
Basically, what we did was, some QA products do come up with some formulas, and I don't know if that is actually available, that formulas are available for us to use or not, but we actually came up with our own formula for creating the predictive analytics. Within Excel. We just used Excel. Excel is all you need.
And then that gives you like confidence interval, whatever your algorithm.
Yeah.
Confidence interval.
Yeah, so we calculated two things. One was the predictive analytical score, right? The score, and then we calculated what is the score. The way we interpreted it was that score was the amount of effort we needed to make sure QA completed on time, and the confidence score, that percentage, gave us the information of how confident we were. If it was 50, hey, we are only about 50% confident we can finish testing for the next sprint. So now it's the time for when you are doing your next sprint grooming, you want to be very mindful of what stories you want to add. So something very simple like that. And what we used for the real-time dashboards, it's all ELK stack. So all of it is an open source system. We don't use anything that is a licensed tool, especially for the dashboards. And the dashboards...
Well, with the exception of PractiTest. We do use their dashboards, right, for our manual tests. And the one thing I wanted to add to Latha is Excel spreadsheets for a small company, great. If you have a small size, but our QA team that uses PractiTest right now is about 130 users. So that Excel spreadsheet, for something that complex, but again, our projects are 5-year projects, 3-year projects. So, sorry, Latha.
Yeah, no issues. That's a good point. But we also use ELK stack, the Elasticsearch with Kibana for building the dashboards. And the beauty of it, the way we use it is, let's say, we are working with a large automotive company, and they have these trends. Every time the same year, let's say a new launch happens, what were the test cases we used for the previous year? We don't have to rummage through our Excel or our test tools to go look at it. We can just look at what are the test cases we used for that particular sprint. It gives you, this data is available right away, and you don't have to actually go through, put someone full-time for a day to go look at that information. Yeah. Any other questions?
Comments?
This is definitely a thought-provoking session, I must say. But on the point, whatever earlier he asked, other than, so we are basically from automation and performance testing background. Do you think we can implement this predictive analytics with just Excel, and then fine-tune what needs to be automated, what needs to be executed from our automation suite? All that analytics.
Yeah. So think about this. When you are looking at, especially within the load performance, right? Every time you have, if you are working on the same scenarios, right? If you're working on, let's say it's an e-commerce website, you are going all the way from login to check-in, and you're measuring different, you're adding different weightages to how many do I want, how many users do I want for login versus how many do I want for maybe a product search, how many do I want to go to cart, right? Within this, what is your biggest pain point right now that you have? Is it the duration of the time that your tests are running? Sometimes you can have load tests that run because you have, maybe there is problems with your API, right? The services are not returning data on time, or you see large number of failures. Once you understand that information, it's easy for you to go provide that feedback when you go do your second set of load performance tests. You are now working with the product teams, with the developer teams. It may even give you an opportunity to say, let's say the developers say, oh yeah, we fixed all of these API issues. You may want to come in and very quickly sneak in an early performance, right, just to see are those issues fixed before you go run, especially for load tests. If you're doing a large load, that is a waste of resources if you know that, if you don't have confidence that test is even going to run or not, right? So to me, yeah, it would absolutely add a lot of value. And we use the dashboards for showcasing all of the load performance metrics. So that way we can look at every service that you have, every service that you're testing, or every page that you're testing, and what was the test results for each one of them. We do that. And where did it fail? Was it like, and anyway, if you are using JMeter or Load Runner, that information, that analysis is available for you. So we use those all the time. Any other questions for us?
Thank you very much for attending, for listening, for all going to the right side of the room. So appreciate your patience, and enjoy the rest of the day.
Thank you so much.
Thank you.